Hello, space enthusiasts, and welcome back to our channel. Get ready to have your minds blown, because the universe has just thrown us another curveball. We're talking about a visitor from beyond our solar system, an interstellar comet that's not just passing through it, putting on a show that has astronomers completely captivated and, frankly, a little baffled. This celestial wanderer is named 3I-ATLAS, and it's the third interstellar object we've ever detected. But this one is special. Since it was first spotted back in July 2025, it's been the talk of the astronomical community. Now, it's decided to do something truly bizarre, adding a whole new layer of mystery to its already fascinating journey. So, what exactly is 3I-ATLAS? The 3I in its name tells us it's the third interstellar object confirmed. The first was the strange, cigar-shaped Oumuamua in 2017, followed by the more comet-like 2I Borisov in 2019. But 3I-ATLAS is in a league of its own. It was discovered by the Asteroid Terrestrial Impact Last Alert System, where the Atlas part comes from a network of telescopes in Hawaii designed to spot near-Earth objects. But on July 1st, 2025, it found something much, much farther away. What makes 3I-ATLAS stand out from its predecessors is its sheer size. While Oumuamua was estimated to be just a few hundred meters long, and Borisov about a kilometer across, 3I-ATLAS is a veritable giant. Early estimates, published in Live Science, place its diameter somewhere between a staggering 5 and 11 kilometers. To put that in perspective, the asteroid that wiped out the dinosaurs was likely around 10 kilometers wide. This isn't just a visiting rock, it's a massive, primordial relic from another star system. An object this large and this rare gives us an unprecedented opportunity. Think of it as a cosmic time capsule, carrying pristine materials from the nebula where it was born billions of years ago, somewhere else in the Milky Way. By studying its composition, we can get clues about the building blocks of planets in other parts of our galaxy. It's like a free sample from an alien world delivered right to our cosmic doorstep. Naturally, as soon as it was identified, telescopes all over the world and in orbit swiveled to get a look. The astronomical community has been tracking its every move with a mix of pure excitement and scientific precision. Every new image, every bit of data, helps us piece together the story of this incredible visitor. We've been watching it brighten as it gets closer to the sun, its icy surface vaporizing to create a beautiful, glowing coma and a classic comet tail. But then, something strange happened. Something that defied our expectations. Comets are often called dirty snowballs. As they approach the sun, the heat causes ice to turn directly into gas in a process called sublimation. This gas, along with dust particles trapped in the ice, gets pushed away from the sun by solar wind and radiation pressure, forming the iconic tail that always points away from our star. It's basic celestial mechanics, something we've understood for centuries. But 3I-ATLAS isn't playing by the rules. Among the many fascinating things about this comet, one feature has left astronomers scratching their heads. It has grown yes, you heard that right, an antitail. It's a second, fainter tail that appears to be pointing towards the sun, in the complete opposite direction of the main tail. It's like the comet has its tail on backwards. How is this even possible? It seems to defy the very physics that govern comets. Now, before we jump to conclusions about alien technology or new laws of physics, let's break down what an antitail actually is. It's not really a separate tail pointing the wrong way. It's more of a geometric illusion, but a very specific and telling one. An antitail is an optical effect that occurs when Earth passes through the orbital plane of a comet. Imagine the comet is leaving a trail of breadcrumbs as it orbits the Sun. These aren't tiny crumbs, though. They are larger dust particles, millimeters or even centimeters in size. Unlike the fine dust and gas in the main tail that get pushed away quickly by solar radiation, these heavier particles are not easily swayed. They are left behind along the comet's orbital path, spreading out to form a thin sheet of debris in the same plane the comet is traveling in. Most of the time, we view this sheet of debris from an angle, and it just blends in with the main tail. But when our planet, Earth, crosses that exact plane, our viewing perspective changes dramatically. Suddenly, we are looking at that sheet of dust edge on. The parts of the dusty trail that are lagging behind the comet on its far side from our perspective can appear to project out from the comet's head in the direction of the Sun. So, this strange, sunward pointing spike isn't gas defying the solar wind. It's a line-of-sight trick, showing us the trail of heavier dust the comet has already left behind. The appearance of this antitail on 3IATLAS is incredibly significant. It tells us that this interstellar visitor isn't just a lump of ice and rock. It's actively shedding large, coarse grains of dust. This is a crucial piece of the puzzle. The size and distribution of these dust particles can tell us a lot about the conditions in the protoplanetary disk where this comet formed, countless light years away. Observing this phenomenon is a race against time. The antitail is only visible for a short period while Earth is perfectly aligned with the comet's orbital plane. Astronomers are using this precious window to analyze the sunlight reflecting off these particles. By studying the light spectrum, they can determine the composition of the dust. Is it similar to the dust in our own solar system? Or is it made of something more exotic? The answers could reshape our understanding of galactic chemistry. This event also confirms that 3IATLAS is behaving much more like a classic comet from our own Oort cloud than the previous interstellar visitors. Oumuamua didn't show any cometary activity, which is why its true nature is still debated. 2I Borisov was clearly a comet, but it didn't give us a show quite like this. 3I ATLAS, with its immense size and now its prominent antitail, is providing a masterclass in cometary science with an interstellar twist. The fact that it's the largest interstellar object we've ever seen might be why it's producing such a spectacular display. A larger nucleus means a larger reservoir of ice and trapped dust, capable of generating a more substantial and complex tail system. It's a dynamic, evolving object, changing day by day as it continues its journey through our solar system. What's next for 3I Atlas? It will continue its path, eventually reaching its closest point to the Sun, before being flung back out into the void of interstellar space, never to return. But the data we are gathering now will be analyzed for years, maybe even decades, to come. Every observation is a piece of a story that began in another solar system, eons ago. We are just temporary witnesses to one chapter of its epic journey. This comet is a powerful reminder of how connected the galaxy truly is. Objects are not confined to their home star systems. They can be ejected and travel for millions of years before encountering another one. We are living in a golden age of astronomy, where technology, like the Atlas survey, allows us to spot these faint, fast-moving visitors from other stars. Each one, from Oumuamua to Borisov, to the magnificent 3 IATLAS, adds a new paragraph to our cosmic story, revealing a universe that is far more dynamic and surprising than we ever imagined. Thank you so much for joining me on this cosmic adventure today. It's truly incredible what's happening out there. What do you think about this backward-tailed comet? Let me know your thoughts in the comments below. And if you love learning about the mysteries of space, make sure to hit that like button and subscribe to the channel so you don't miss our next update. Until next time, keep looking up